Today we are going to be working on chapter 9 some more. So we're going to go ahead and get started. What you should have gotten today, let me share my screen. Sorry about that. You should have gotten this page. That's not the page. I'll get it together, guys. You've gotten this page. There we go. And so this has your calendar, so you can see that we are going to spend several weeks, 2 full weeks, plus a little bit, 3 full weeks plus a little bit. I'm not sure. But we're spending a good bit of time on chapter 9. You can see that there's lots of practice problem days built in. There is a lot of math in this. You are going to want to have your periodic table with you and your calculator every day. Okay. Like I said a couple of days ago, with stoichiometry, what we're doing is it's just a terrible, terrible sounding chemistry word, but it means conversions. Okay. Specifically, we're going to be looking at reactions, and we'll get into that a little bit and really the actual like chemistry definition of it. But what we're doing is converting between different units and different amounts of substances and figuring out how can we really measure that and how much do we actually need. So it sounds horrible and terrible, but if you learn the process, it's really not that bad. We're going to start off really basic today. So let me move this out of my way so I can actually see what I'm doing. So you should have your calendar, and then your review is on the back side. There were a couple of little typos where the arrow didn't print correctly. I think I went in and fixed those, and I know I wrote it in on your review. So you have your review. You could theoretically get started, but probably won't. You should also have a set of notes for today, which are going to take their time to load up. The notes are not very long for today, but there is another page of practice problems that go along with that. So once we finish the notes, hopefully like 10, 15 minutes, and I'll go through this with you through the PowerPoint. That's why I'm doing this video. And then when we finish with that, you can work on the practice problems on your own. They're very basic. You will be able to do them. We've actually kind of already done some of them before. In chapter 8, kind of introduced this idea. You just don't remember it. It's fine. I have left an answer key. It just has the actual answer, so you can check to see if you're right. I'll try to do another video that has a couple of them at least worked out. And then you'll have a homework page that you'll get towards the end once you're pretty comfortable with this. The homework page is pretty straightforward, matches pretty decently what we're talking about on the video and with the PowerPoint. So I will make sure to put the PowerPoint up on Classroom along with this video, so that if I'm going too fast, you can go back and look at stuff. And of course, you always have your textbook as a reference, so you can go and read the words. Okay, so let's get started with the actual notes. So again, you guys can pause this video anytime you need to. It's a video, rewind, rewatch it, okay? And then I will put it up for you guys to view anytime you think you need to help your reviewer as you're working on the homework. You've forgotten, it'll be available to you. So we are doing stoichiometry. This is just the introduction. Lesson 2 has a little more in depth, and I'll kind of show you, give you a little preview of that and terrify you just a little bit at the end of the lecture today, at the end of the video. And then lesson 3, we're going to split into 2 parts for sure. Lesson 2, we split into 2 parts. And then lesson 3, we'll do in 2 parts as well, where we're kind of giving a little more practicality of why we would need stoichiometry. Why is it actually useful, specifically in chemistry, and where would you actually need to use these equations, not really equations, but these conversions. All right, so There's two types of stoichiometry. A lot of times you'll see people abbreviate it, even when they're talking, and call it just stoic, because nobody wants to say stoichiometry all the time. So there's two forms. There's composition and reaction. Composition stoic is, if you remember, way back when in like chapter 7, before Thanksgiving, we talked about percent yield. No, we didn't. That's the wrong one. Percent composition, where we found the mass of the whole compound and then found the mass of like each element and what percentage of that whole compound was each element. And that would be an example of composition stoichiometry. Okay, you're looking at the elements versus the compound as a whole. So what is the relationship of those masses? Okay, so and we talked about like the law of multiple proportions and stuff like that, where you can have the same elements that form multiple compounds, and they always form those compounds in like whole number ratios and stuff. It was weird. You probably don't remember any of it, and I'm probably just confusing the mess out of you. That's okay. What we're going to focus on in this chapter is reaction stoichiometry. So we are going to be looking at the relationship between the mass of the reactants and the mass of the products, and how we can use the mass of our reactants to figure out how much product we would get or how much of another reactant we would need. So that's kind of the goal with this, is being able to take the mass of one of our substances and calculate the mass that would be needed or the mass that would be produced of one of the other substances. Okay, so you have these two definitions that you will need to know. For sure, you need to know reaction stoic, okay, because that's what we're doing. There are 4 different types as described by your book. 4 different types of these reactions or problem types that we're going to be doing. We're going to focus today on just this first type. So I've summarized them here for you, where you have these 4 types. The first type is the simplest, where you're given something in moles, and then you use that to calculate one of your other substances. How many moles would there be? Okay, so we're going to use what's called a mole ratio. I'll talk about that more in a second. That one's going to be your best friend. You really need to know the mole ratio. We'll go through each of these types in lesson 2 next week. We'll take a day to do problem types 1 and 2, and then another day to do 3 and 4, I think is how that is divided out. Just so that we can get lots of practice in, go nice and slow, no need to overwhelm you. So with each of these, you're given some number in the problem, and then you're supposed to find something else. So with problem type number 1, you have 1 conversion factor that you're going to use. With problem type number 2, you're going to be given something in moles, but they want you to find the mass of one of the other substances. So we would convert first to the moles of our unknown, and then, if you remember molar mass, we'll convert from molar mass, or using molar mass, to the mass of our unknown. We can go the opposite way with that as well. That's problem type 3. They give us the mass of something. We would convert that to the number of moles. And then from there, we would do a mole ratio and find the number of moles of whatever the other thing is. Okay, the other substance that they're asking us to find. Problem type 4 takes the most steps. It's not necessarily any more complicated. It kind of combines types 2 and 3. So you're just taking more steps. So you're given something in grams, and they want to find one of the other substances. They want you to give the mass. So they give you something in grams. We'll convert that to the moles, and then do a mole ratio. Again, we'll talk about that in a second. Don't freak out if you're like, I don't know what that is. It's okay. And then go from moles of your unknown substance to the mass. Okay, so each of these has a certain number of steps that you have to take, of conversions that you're going to use. None of them are difficult. It's a matter of paying attention to what you're doing, making sure you know what you're given and what they are asking you for. If you pay attention to that, and you pay attention as you go step by step, you're going to be fine. Okay. It's a little bit detail oriented, a little bit, cannot think of the word, but it'll come to me later. But you just have to pay attention and focus on what you're doing. Okay. Trying to do this while you're in the middle of another class is probably not going to work well. Or while you're watching TV, probably not going to work really well. You need to be able to focus. Okay. And you need your calculator. All right. So I talked about this mole ratio thing. The mole ratio is just a conversion factor relating the number of moles of any two substances in our reaction. So if we have a balanced equation, you do need to remember how to balance an equation. That's not going to go away. We start with our balanced equation here. And we can use, if you remember, we can use these coefficients here. They can be used to describe the relative number of moles. Okay, so this is saying I have 2 moles of aluminum oxide in this case, which will produce 4 moles of aluminum and 3 moles of oxygen when we do this reaction. Okay. So I can create a mole ratio to relate any two substances in this equation. Okay, so I can relate my aluminum oxide to just aluminum. Okay, so I have 2 moles of aluminum oxide for every 4 moles of aluminum. I can relate the aluminum oxide to oxygen, 2 moles of aluminum oxide to 3 moles of oxygen. And I can relate aluminum to oxygen, 4 moles to 3 moles. Okay, because it's a conversion factor, I can also have the inverse of each one of these. So I can use this either direction depending on what I need it to do, what I'm trying to convert from and go to. Okay, so let's look at an example. So how many moles of aluminum can be produced from 13 moles of aluminum oxide? Okay, so this right here, the 13 moles of aluminum oxide, go back. 13 moles of aluminum oxide, this right here, I don't know what just happened. Okay, this is my given. Okay, this is what I'm given in the problem. All right, and then this over here where it asks me how many moles of aluminum, that's my unknown. Okay, so I have my given and my unknown. That's a U. Doesn't look like a U. That's okay. So I'm going to need a conversion factor. I need to pick the correct mole ratio that will let me go from moles of aluminum oxide to moles of aluminum. So if I go look at my list again, let me erase all this. I go look at my mole ratios that I have here. I'm going from moles of aluminum oxide to moles of aluminum. I want my aluminum oxide to be on the bottom because if we look back here, let me go back. Okay. I'm given aluminum oxide and I want that to go away and be left just with the aluminum. And I'll show you what I mean by that. So I need this equation right here, this conversion factor. Okay, so I want my aluminum oxide to be on the bottom and my aluminum to be on the top. Because when I set it up this way, I start with what I'm given, the 13 moles of aluminum oxide. And then I like to do the train tracks. If you don't like the train tracks, you can just set it up as like multiplying by fractions, whatever works for you. If you're really confused by this method, shoot me an email or let me know somehow, and I will try to do one where it's not with the little boxes. Okay. So I start with my moles of aluminum oxide, and then I put my correct conversion factor in, my mole ratio here. So I have 4 moles of aluminum from that balanced equation to every 2 moles of aluminum oxide. When I set it up this way, my moles of aluminum oxide cancel out or they divide out. So when I get to my answer, I'm left with moles of aluminum, which is what it asked me for. So I do the math. I do 13 times 4 divided by 2. Remember, you can kind of do this in any order. 4 divided by 2 is 2. So 13 times 2 gives me 26 moles of aluminum. Okay, so there are some of the that's wrong. Okay, never mind. Sorry, I thought some of the practice problems had just mole ratio questions for you, but that was problem type 1. Okay, you're given this many moles. How many moles of one of the other things can you get? Okay, so you're just using that mole ratio. That mole ratio, you're going to need one every conversion that we do in this chapter and probably beyond. Okay, but for sure for this chapter, you're going to need to know the mole ratio and how to find it and how to put it in there correctly, which one you need and where it should go. Okay. All right, we talked about molar mass already earlier this year. Molar mass is defined as the mass of 1 mole of a substance. So remember, 1 mole is that Avogadro's number of particles. Okay, it's like saying a dozen, but a dozen sugar cookies are not going to have the same mass as a dozen eggs. Okay, so each substance, each element or compound is going to have a different mass for 1 mole. So I took these, this was an example from your book. So I just took them straight from the book. You can round to the nearest whole number. I'm still good with that. On your test, you're going to have numbers like this because your book goes to 2 decimal places. Okay. So it's technically more correct. I just let you be a little bit lazy. So if your answers are not exactly matching, it may be a rounding error, just that you go to 102 and not 101.96, for example. So we have 1 mole of aluminum oxide is 101.96 grams. So I can get 2 conversion factors from each one of my substances in that equation that we're using. So I have moles to grams, or I can do grams to moles. Either way, and depending on what I'm being asked to do in the problem, I might need either one of them. Okay, so here's one example where we have the mass. We're finding the mass of 26 moles of aluminum. So we take what we're given in the problem and we write it in the top left. Then we set up our boxes to do our conversion. Because it's asking me to find the mass, we're going to use the conversion factor where the moles are on the bottom, so that again, the moles will cancel out. Right, so my moles of aluminum cancel out and I'm left with instead the grams of aluminum. Okay, so when I do that math and I multiply those 2 numbers, I would get 701 grams of aluminum. Okay, so here is just a little summary of what we have done, especially that first conversion where we were converting from moles of some known substance to moles of an unknown substance. So the problem, it's going to tell us the amount in moles of one substance. So that's our known, right? Because we know what it is. They told us. And then we'll use the coefficients from a balanced equation. So you always need to double check that the equation is balanced before you start doing this and trying to find the mole ratio. So you put your known substance will always go on the bottom and your unknown will go on the top. And then you multiply the original amount by that ratio. Okay, multiply what's on top, divide by what's on the bottom, and that gives you the moles of unknown. Okay. So that's really all of today's lesson. I'm going to show you a picture. It's probably going to freak some of you out, but this is where we're going. So today what we did was this right in here. You were not letting me draw. Right in here, we did this, okay? We went from the moles of one substance to the moles of another substance, okay? We actually even did a little bit of going from moles to mass. Okay, you can go from mass to moles first. So you can start, so this diagram is very complicated, but you can start at any point and end at any point. And that's what we're going to be working on in the next few, for sure in lesson two. Lesson two, we're going to focus on adding in, starting with the mass and going to moles, or starting with the mass and eventually even going to the mass of our substance. Okay, so from moles, we can go to almost anything. From here, we could figure out the number of particles or the number of molecules. And we did that in chapters 7 and 8 with Avogadro's number. Okay. In chapter 11, yes, chapter 11, we're going to bring in volume. It might be a little bit in this chapter where we're going to use the density as our conversion factor and be able to use the to find the volume or to be given a volume and still calculate from the volume of one thing, how much of another thing do we get? Okay, so if this part is confusing or scary to you, rewind the video, go back a little bit, and then stop it before I get to this slide, and then just pretend like this part never happened. Okay. So hopefully we're okay, at least on going from moles of one substance to moles of another. If you can do that and you can do a molar mass conversion, you're good. Okay. So the practice problems are all molar mass. Okay, so you're either given something, either tells you we have this many moles of a substance, find the mass, or it says we have this mass, how many moles do we have? Okay, so that's all you're doing on the practice problems. Okay, here, and again, I left an answer key so you can check that you're doing it correctly. And I will try to do a video to help that out. The homework, you have 4 multiple choice questions, and then there are a few more questions. There's 8 total, but several of them have parts. So it probably works out to about 20 actual questions. Where you're given an equation, you may need to balance the equation. I know in number 5, it tells you to balance the equation. And then finding mole ratios, and then based on those mole ratios, being able to do some basic calculations. Okay, so do your best. You can send me a message if you have problems or questions, and I will do my absolute best to get back to you, but I make no promises about any sort of like timeliness on that. But let me know, and I will try to get back to you if you are having problems and you need to ask some questions. All right.